Hello everyone. So in the last video we measured these resistances for this particular small resistive network, and now in this video we'll try to start calculating these values and we'll try to match these values. So just a brief recap, this is a small resistive circuit with 6 resistances. You can see the resistances elements are also here, and at the back these are the connections. These connections are as per this particular circuit diagram, which I have just drawn it here for your convenience. So we already measured all these combinations resistances as shown here. So let's just for recap, I'll measure only RAB and then we'll do the calculation. So for measuring RAB, again I will use this resistance measurement device, and I'll just measure. I mean, it doesn't matter, RAB or RBA, both will come same. So the value that I am now getting is somewhere between 46 and 47. I'm sorry, let me just hold still. That is 146. Okay, and that's exactly what we had got here before. So 146. So let's try to calculate and see whether we get 146 or not. So for calculation, we use simple series parallel circuit calculation. So RAB calculation. So I begin by drawing the circuit as it is. So we can see here. So I have, so all the resistances are in kilo ohms. So kilo ohms means 1000 ohms. So this is 220 kilo ohms, like that. And the objective is to find RAB, which means successively, step by step, I would like to eliminate the other resistances. So here, eliminate in the sense I have to simplify it. Okay. So here I'll begin by drawing the exact circuit. So this is 100K and this is 68K, and here we have 560K. This node is C, and here we have 820K, and finally we have 330 kilo ohms. So just to recall, if two resistances are connected in series, so R12 is R1 plus R2. This is if two resistances are connected in series, we just add them. In fact, if n number of resistances are connected in series, we just add all of them to get this one. So in this example now, because my interest is in points A and B, RAB, so this particular branch, if you notice, so this 100K and 68K will become series connected. So like that. And in the case of parallel connection, so RAB is RB divided by RA plus RB. Okay, so again we had in the previous videos we might have worked out this formula. So if RA and RB are two resistances in parallel, then the effective resistance RAB will be like this. Excuse me. Now in this example here, 560 and 820 are in parallel, because again I am interested in points A and B, RAB. So therefore between B and C, these two are in parallel, whereas the other two, 100 and 68, are in series, and we can simply eliminate the D. So let's simplify this circuit. So step by step I'll keep simplifying this circuit. So I have here this 220K will remain same, and here I want to get an equivalent resistance of these two parallel combination, 560 parallel with 820. Okay, so 560 into 820 divided by 560 plus 820. So this value will come here. So this is the parallel combination of these two, and above I already have this 168K. So 100 plus 68 is 168 kilo ohms. I just kept it there. This I will calculate, and of course we have another resistance like this, which is 330 kilo ohms. Now what is this value? So let me calculate that. I'll just pick up the calculator. So I have 560 let me go into the scientific calculator mode. So I have 560 multiplied by 820 and divided by, I'll open the brackets, and 560 plus 820. So I'm getting 332.75. Okay, so let's write that 332.75 kilo ohms. So because the numerator, these are all in kilos, the answer also I'll get in kilos. So again, be careful with that. 332.75 kilo ohms. Now this point is C and this point is B and this point is A. Now I can further simplify. These two are in parallel, so I can find a parallel of that. So again, simplifying further, I'll get, so this 220K is same. So here I'll get a equivalent resistance. This is B, this is A, and this is C. So what is this? This is 320.75 parallel with 168. So I'll right away do it. See, I already have one of the values. So I just multiply by 168 and divide, brackets open, 168 plus 332.75 and brackets close. So I get this number 111.6. Okay, so 111.64, let me take it, kilo ohms. Okay, so this is the equivalent resistance of this. Meanwhile, I have this another resistance 330 kilo ohms. So again, my interest is to find resistance between A and B. So between A and B, that means this resistance will become series with this resistance, because my points of collection is from these 2 points. So from that perspective, these two are in series and C can be eliminated. So ultimately, again, in the next step, I get 220 kilo ohms as A and B, and parallelly I'll get 330 plus 111. So I'll just say 441.64 kilo ohms as the resistance. Okay. So again, now these two are in parallel. So therefore, I can simply now finally get the equivalent resistance between AB by calculating these two. So again, let me do that. So how do I do it? So 220 multiplied by 441.64, then divided by 220 plus 441.64. So I am getting 146.85 kilo ohms. Okay, so this is a value, and if I go back, what was our measured value? The measured value was 146 kilo ohms. So now I am getting 146.85. Let me write it here, 146.85 kilo ohms. Okay. So what is the percentage error? Okay, so in order to find the percentage error, we'll take the calculated value as the reference and the measured value, because we want to find the error in the measured value, because this is our designed value and this is what we manufactured. So what is the error? So for that, the formula is, I just divide this divided by the calculated value. So I'll just do 1 by x on this and then multiply it with 146. Okay. So this is 99.42%. That means for the actual value, we are able to match almost within 1%. Okay, so if I again subtract it 1 from it, so minus 0.005, or the error, let's say minus, for calculating in percentages, I have to multiply with 100. So minus 0.57% is the error. Okay, so as long as error is between 1% or 2% or even 5%, it is good enough. Now the next job is to fill this again the table. So we need to now find RAC and then do the calculation. So which we'll do it in the next video. But then here you can, I'll just leave you back once again. We started off with this, then we got the objective was to find RAB. Then I took this circuit, 168 are in series, so 168, 560, 820 parallel becomes 332.75. Then these two in turn are parallel, it becomes 111.64, and then this is a circuit, and then these two become series, and finally like this. So the skill here or the learning here is to identify which circuits will become series and which circuits will become parallel according to the interest that we are having. Okay, over to the next video in which we are going to calculate resistance between RAC, which is resistance between A and C. Thank you. If you find this video interesting, please like and subscribe.